We are talking today about an update on Cray. And first of all, the most important thing that is happening in these hours is the fact that Cray has been acquired by HPE, and HPE has completed the acquisition of Cray. Now I need to change my badge. This acquisition is very interesting because is a situation where one very important company like HPE, leader in, I would say, in the commercial HPC, and Cray, leader in the government high-end HPC, are combining together to create a very, very interesting company that can give to customer a lot of value, a lot of innovation. The fact that Peter Ongaro is leading this business unit inside the HPE for not only HPC but also artificial intelligence means that HPE would like to invest even more in this area, continue the development of HPC product. And we are hoping that for the supercomputing, we will be able to brief you on the new combined roadmaps. So please contact your HPE and your Cray account executive to schedule a meeting during the Denver event to see what we can provide to you for the next few years. What we have today is the fact that Cray is executing on Exascale. We have awarded on 3 large projects. The first one, the Aurora project, Cray is a subcontractor of Intel. Intel is priming in that and is providing a solution based on a GPU technology that they announced recently. There are other 2 projects, Frontier and El Capitan, where Cray is in this case priming, and it's the experience that we are doing executing this Exascale project is not limited to the DOE ecosystem, but has a direct impact on all our customers. So the solution, the Shasta solution, that is the cornerstone of this technology, will be available for all the customers. So an exaflop, or as probably not all of you know, an exabyte storage solution that we will provide for Frontier has developed in the same way on a few cabinet solution at lower scale. So basically, the Cray product that we are providing on the market today are able not only to scale at exaflop and exabyte level, but also provide innovation and value to customers that are, for example, in the weather modeling field or in the artificial intelligence ecosystem. So those are examples of lower scale at Indiana University, for example, and in other customers in US. So which are the trends that we are seeing in the Exascale that will be available into the Shasta products? First of all, we realize that the Moore law is slowing down, and probably we will have a couple of other shrink before we or our partners, our technology partner, we start to stack the CMOS in the processor. And we don't expect any more optimization in the performance per watt. kind of technology. So what is important for a Shasta solution, for a solution that needs to scale in the exascale area, is the fact that we must provide the solutions that are able to accept a very high TDP processor. At the same time, the heterogeneity of solutions, so you will expect a different kind of processor, accelerated or not, APU on the market. So, and this is another things that OEM like Cray need to understand and challenge. Cloud is a very important new way to access HPC infrastructure. Many of you know that there are new users of legacy system that would like to have a more interactive way to access the system. So there is innovation in new tools like Jupyter Notebook, where user would like to have no more a batch-oriented system, but a more interactive system. And then, as Nick mentioned before, new memory hierarchy, HBM from DDR to HBM to this new NVDIMM. So all of these are bringing us to a very difficult exercise to have a strong recipe for Exascale. But with the experience that we had during the discussion with the DOE labs, we arrive at the conclusion that there is a recipe for exascale computing. And this recipe starts with a very powerful interconnect that is gluing all these elements together, but is also innovative and can give you the possibility to run seamless HPC optimized application and cloud-based, Ethernet-based application. In a scalable infrastructure with processors that are able to achieve the exascale performance with a software that is able to adapt and be more flexible. And all of these in a kind of 35 megawatt domain, preferably less if you don't want to burn all your money in Apex. So the big innovation that, in my point of view, we put in Shasta is our new interconnect, Slingshot. The Slingshot interconnect is based on Ethernet. This shouldn't surprise you. If you see the top 500, the majority of the system on the top 500 are Ethernet-based. Of course, the top 50, the top 100 is a different story. And this is where Slingshot is very capable of. We are using libfabric to optimize HPC application to move data in the HPC domain. And we use RDMA over Ethernet for clients and applications that are more cloud, more Ethernet oriented. So you can have both. You can use both the domain to optimize your application. And this tackles the most important problem, in my point of view, on a production system. So the tail latency of your application and the congestion problem of your busy system. And we have the fortune to have our research center for Slingshot in Bristol. we have some expert of GROMACS, and I had the opportunity to run some tests on GROMACS, comparing the same system based on Intel Skylake using an Aries network and a Slingshot network. In the gray bar, you can see the performance of GROMACS using an exclusive mode. So 4 AM, a system completely empty, you run only GROMACS. But if you run in a busy system where you have other customers working, you see the impact on GROMACS of the performance. And in Slingshot, thanks to the congestion control system, thanks to the very low latency, we achieve a performance that is the same of exclusive mode. This is what we call sustained performance. This is what differentiates ourselves. So we have flexible infrastructure, ultra-dense optimized cabinet able to sustain 300 kilowatt in free cooling warm water, fanless solution, or we can use standard 19-inch rack with the same interconnected, the same software environment. We are able to support a very heterogeneous number of processors, starting from AMD to Intel, Intel GPU, NVIDIA GPU, AMD. Same network, same Cray programming environment in all these environments. And in the future, I should mention that we are supporting also ARM. But the most important thing also to me is the fact that we rewrote completely the Shasta software stack. In the past, the Cray environment was a little bit, I would say, closed. With the new Shasta software, you can, in the future, then dynamically partition your system and dedicate a partition for classic workload manager, SLARM, PBS Pro, whatever you want, and another partition for Kubernetes scheduling. So in this case, you can have a batch-oriented partition and a more interactive partition where user can pick up their container and schedule into Kubernetes directory, or use your Jupyter notebook and interact directly with the system. So this is what we are doing. We start with the management system that will be based on Kubernetes and Ceph, and then we extend the Kubernetes domain into the system itself. And also all this Shasta innovation will reflect also in the storage part. Cluster Store will continue to progress. We have a great plan on the storage part for hard drive-based solution, with more efficiency, more density, better management and support, and in all-flash solution. Again, for Frontier, we receive a request from DOE to provide an exabyte class solution. And that's all for me.